Hi, I'm Dr. Peter Leong. In this series of videos, I'll be talking about the AI and high performance computing infrastructure or HPC infrastructure. So this series of videos is basically to explain to you the nuts and bolts behind what enables you to build these large and complex machine learning models and deep learning models that we have been talking about in the other units of this course. So here is the overview of the contents. So we first talk about the background or the overview, and then we're going to talk about a very important concept called containerization. That is the backbone of many of the modern AI pipelines when it comes to operating in a HPC environment. Then we're going to talk about how we are able to make use of the graphics processor unit or GPU to accelerate the computations. So actually GPU acceleration is quite fundamental in enabling the modern AI age. Without this accelerator, we would be not be able to train very large models because the computational power available on your conventional co conventional CPUs or processor units, they are not powerful enough to actually do the training for deep and complex neural networks. So just first the overview or the background. So first of all, maybe to set the stage, why are AI scientists so concerned about performance, right? Why do we need to be able to perform the training very quickly? So as for the data scientists or AI scientists, one of the main concerns is being able to train and tune the models in a shorter period of time. By having this facility or having sufficient resources to be able to do the training in a shorter time, we are able to actually have the time to actually have more cycles of refinement before delivering the final product. This is actually always a challenge because the creation of a model, the building of a model is an iterative process, and if you are never able to create it in just one single cycle, then you want to have as many cycles as possible before the deadline actually draws near or comes to a close. Right, so having that shorter turnaround time, that shorter training period, and also the shorter period for tuning, we are able to do many more cycles of refinement before we actually come up with the final model. Now, AI scientists and data scientists also do not want to be concerned with the nuts and bolts of how actually we can reduce the time to do the training. All we want to do is really to be able to do this main work function of tuning and building the models as quickly as possible. We don't really want to be concerned with the nuts and bolts of making this possible. In other words, the infrastructure and the engineering behind what makes these fast computations and acceleration with GPU possible. But however, for a student or a learner in this area who's going to make use of these facilities, I think it is actually important that you have some appreciation of how this glue actually works, right? How do we actually put the various pieces together to enable this rapid training and fine-tuning of your models? Another constraint really is that there may not be sufficient RAM or storage space to store your training data as well as the model. So scientists need to be able to see how uh, their training process can be scaled across multiple resources in a virtual fashion, so that they don't have to be concerned about trying to find just one super large machine. Uh, and how does this actually work in the background, right? When we talk about some of the earlier techniques for scalable machine learning as well as distributed training, how actually does that translate to the actual hardware networking components that we have working in the background to enable those things to happen? So the AI scientists and the data scientists may not be concerned with the engineering to support these large volumes of data, but they certainly need to make use of the facilities. So I think the purpose of this set of videos really is to give you some appreciation of what goes on behind the background to enable these things for all these facilities for the data scientists. So for the After the training stage, which requires a lot of computational power, and we just talked about that just now, then comes the inferencing or the prediction stage. So after you build the model, you want to use the model in a production environment to make predictions for your users. This comes with its own set of challenges, but the two fundamentals just now, higher computational ability and also larger memory, is also required for this stage. But in this stage, actually, maybe the training time is not important, because we would just use the pre-existing train model to make the predictions rather than do the training all over again. But we still want to be able to make the inference or the prediction very quickly using the model. Because if we want to serve a large number of users, even though we are not having a large training time and we have a short prediction time, let's say you have a 1 millisecond prediction time. In 1 second, you can serve 1,000 users. Okay, if you do the service one by one. If you have 1 microseconds of prediction time, then you can serve 1 million users within 1 second. So even in the production stage, there is actually a requirement to be able to do the computations very quickly, but we are talking about much smaller time scales than for training. So it's okay if your training takes a few days, but when it comes to inferencing and serving large number of users, you cannot be using a few days to make a single prediction, because your users will not be so patient and they will not use your service if you take that long to do it. So we're talking about a much smaller time scale, but we're going to do it much more frequently, right? Because we need to serve a lot more users than during the training process when we actually just build one single model. But here we are using that one model that's been built to serve thousands or even millions of users. So we need that speed or fast turnaround time in making the predictions so that we can cater for the large volume of users. Now, during the model deployment time, the computation should only take a short period of time. It should be very fast, as there's a need to push out thousands of requests, all right, from the model to your users. So one of the frameworks that we'll be talking about later on is something called the TensorFlow serving, which is a way to actually make this fast. Finally, here are some essential questions that you should ask yourselves as we talk about the infrastructure. How do we shield the data scientists and the AI scientists from the nuts and bolts of the infrastructure? How do we make their life easy to use this infrastructure without having to expose them to the complexities of getting more machines, spinning up more servers, spinning up more GPUs, connecting the networking infrastructure needed to distribute the data across multiple machines? How can we actually sort of remove this complexity away from them, but still enable them to be able to do their job of training very large models? Another question that we would have is that how can we provide a simple way for them to run, okay, their code and having the software libraries without having to worry about whether or not the software that they're trying to run is compatible with the hardware that you have in your infrastructure? Is there a way to shield or virtualize the resources so that with the same hardware you can actually have different combinations of software resources for different data scientists? So this is the other question. So for number one, removing that complexity of connecting the hardware together. The second one has to do with software compatibility. How can we virtualize stuff such that data scientists and AI scientists no longer have to worry about software compatibility and still able to share the same underlying infrastructure to this? So I don't need a dedicated server just because I have to run this software, and I can share this hardware resources across multiple users. Fourth question is there a way that I can write my software so that I can run on a variety of servers without having to worry about the same thing, right? The nuts and bolts of the hardware, software compatibility. So make my software more portable. And lastly, is there a way that once I have actually created the model, I have various options for deployment? I am not restricted to, oh, I must use only Google or I must use only Amazon to deploy my model. Is there an option to actually save my model in a portable format such that I can actually deploy on many different platforms? Or what other ways can we actually enable this easy deployment uh, besides the concerns that I've already mentioned? So we come to the last slide. So just to reiterate, this section is on having you to appreciate some of the nitty-gritties and the nuts and bolts that goes on behind the scene when you run AI jobs over a very high performance infrastructure. There are certain concerns that we try to shield the data scientists or AI scientists from, so that they are still able to do the job without having to understand in great detail the hardware complexities as well as the software complexities that must run smoothly behind the scenes. So those questions that I mentioned just now, how do you shield the scientists, how do you have more portable software, are some of the questions that we want to deal with and find the answer to in the next subsequent set of videos in this set of videos. Right. So thank you for your time and attention, and I'll see you in the next few videos.